Hi, everybody. I'd like to record a short explainer on yield to maturity since I got a bunch of questions about this. It will be probably about 10 minutes long. So, what is yield to maturity? First thing we need to understand is, what does this term yield mean? There's a lot of different yields in finance, and particularly in bond finance. It's a loose term that basically means how much money does an investment, or typically in a bond, make over a period of time. Usually, a yield is expressed as a percentage, and there's lots and lots and lots of different types of yields. So what are the three that we tend to start with when we're talking about fixed income securities? Fixed income is bonds. Coupon rate, current yield, and yield to maturity. The coupon rate is just the annual payment divided by the face value of the bond. So let's say that we have a bond, face value is 1,000. The coupon payment is 80, and the annual coupon payment is $80 per year. So the coupon rate would just be 80 divided by 1,000. Simple enough, 8% is the coupon rate. The current yield is just the annual coupon payment divided by the market price of the bond. So we know that since interest rates change, bond prices don't always stay at their face value. So this may have been issued at $1,000, but let's say that today the market price is 780. So the current yield would just be the coupon divided by the market price. Why is the current yield higher than the coupon rate? Well, for the coupon rate, we paid $1,000 to make 80 per year. The current yield, we paid $780 to make 80 per year. So we're getting more with less. In other words, a higher rate of return. The thing about both of these two is that they don't consider all the cash flows. They only consider the next cash flow, which is the coupon payment. But how do we take into account all of the bond's cash flows, all of the coupon payments over the life of the bond, as well as the return of principal at the end? That number is the yield to maturity. So it is the single interest rate or discount rate that makes all of the bond's cash flows, interest and principal, equal to its current market price, which is the present value. This is the same thing as solving for R in the PV FVRT problems. It's exactly the same thing. R is the interest rate that in those other problems makes the PV, the FV, and the T work. Remember, typically we're given in these present value problems, we're given three numbers and we have to solve for the fourth. So we have to solve for the fourth. And that R is the same thing as the yield to maturity in a bond. So the way this works in practice is that in the marketplace, whenever we buy a bond, we know its future cash flows. We know it's going to pay $80 a year, and we know it's going to return $1,000 at maturity. We also know the current price that the bond is trading at, because we see a price on our screen. We have to figure out when we buy that bond, what is the R that we're buying? And that's the yield to maturity. So let me show you how all this works with an example. So let's say that we have this bond here. It's a 5-year bond. These are the cash flows. This is the interest. And this is the principal. So what's the PV of this? If the discount rate is 8%. What's the present value of these cash flows? Well, each of these, we can just use the basic 1 divided by r raised to the t formula for each of these to get the present value of these 5 cash flows. So the present value of the year 4 cash flow is this. It's this $80 divided by 1 plus r raised to the t, which is 4. So we're discounting to get back 4 periods. These are the interest payments, the present value of the interest payments. This is the present value of the principal payment, this $680. That's also this $1,000, the principal payment, divided by 1 plus r raised to the t, which is 5. And the sum of these 5 is this. And the sum of this is this, obviously. Then you add these two things together and you get this number, which is 1,000, because it's a bond that's paying 8% per year, discounted at 8%, and we buy it for 1,000 and we get 1,000 back at the end. This is the very simple 1 plus r kind of math that we've been doing. But what happens if we're not buying this for 1,000? What if the market price of these cash flows, whenever we buy this bond, we know we're getting these cash flows, and over the next 5 years, and we're getting this cash flow at the end. But if the market price of this is actually, let's say, $600, if the market price, if we have to pay $600 to get this cash flow plus this cash flow, what does R have to be? What R is implied by this market price? That is the yield to maturity. And the way to, you actually just calculate it by brute forcing it. So do you think if the market price is 600, is the yield to maturity going to be higher or lower than 8%? Well, implicitly what happened is this bond was originally issued at face value of 1,000 and the market price fell to 600. Probably because interest rates went up, and they went up significantly. So my guess is that this bond has a duration of close to 5. It's fallen by 40% in value from 100 to 600. So I'm going to guess that this R is around 17%. So what we're going to do is we're going to put in different values for R until this number becomes 600. Not high enough. Getting there. Yeah, very close to 22%. 21.75, let's see. 21 point, try to say 21.9. 21.96. 1.95. Okay, that's close enough. So if we are earning this stream of cash flows plus this stream of cash flows, and the market is offering us this set of cash flows for $600 today, that implies that the yield to maturity is 21.95. Because when we take these cash flows and discount them at 21.95, we get this plus this, which equals this. Why do we care about the yield to maturity? We want to compare the yield to maturity to other investments that we can get in the market. So, for example, in the market, we can currently get this investment for $600. That implies a yield to maturity of 21.95%. Now, do we want to buy this bond? Yes or no? Well, it depends on what else we can get in the market. If we can get stuff in the market that's 30%, maybe this bond isn't a good deal. If other stuff in the market is at 18%, then maybe we want to look at this bond. And actually, we want to ask ourselves, if other bonds are priced to yield 18% and this one's priced at 21.95%, why is this thing offering a higher yield? Because risk and return go together. So if we're being offered a higher return, 21.95%, what is the corresponding risk that we may not be thinking about? So that's yield to maturity. We can discuss more, leave me comments, etc., and we'll see you soon. Thanks. Bye.